I just graduated from Washington State University 2 years ago with my PhD degree with a focus on self-healing concrete. And after finishing 1 year postdoc appointment at Drexel University and almost 10 months at a consulting company, I just come back and rejoin Dr. Shi's group as the assistant director of traveling. Okay, let me share my screen and see. Can you see my screen? Oh, by the way, if you have any questions or problems, please type your questions or problems in the chat box, and I will repeat it. Repeat it and ask for the answers as soon as possible. Yeah, I guess we can begin now. Oh, oops. Let me know. Let me stop sharing. Yeah, I got doable. Okay. Can you all see my screen? Okay. So today I'm gonna talk about a durable self-healing concrete using urea-formaldehyde microcapsules and PVA fibers. So here's the content of today's presentation. I will first start with some background and the innovation of our study and move on with the experiments and sharing some interesting results and findings with you guys. And finally, I will make some conclusions. So first of all, the annual cost of maintenance and repair related to bridges alone in the US is about $5.2 billion. And if the cracks are not visible or it's very hard to accessible, the cost will become even higher, and the repair work will sometimes be impossible to do. On the other hand, the urea-formaldehyde microcapsules with calcium nitrate is a mature and promising self-healing technique for cementitious materials. So we investigated the performance of this self-healing system consisting of urea-formaldehyde microcapsules and PVA fibers on mitigating the early age shrinkage and enhancing the freeze-thaw durability of cementitious materials, which is rarely studied before. And also, in addition, we propose a methodology of how we are going to distinguish the air voids, microcracks, and microcapsules in the concrete matrix based on the 3D X-ray micro-CD results. So here's the synthesis procedure of microcapsules. It's a water in oil polymerization process. We add the aqueous phase containing all the chemicals into the oil phase drop by drop, and we selected 3 agitation rates for tuning the size of the microcapsules. And we prepared 2 types of specimens, which are cementitious composite specimen used for shrinkage test, and concrete specimen for freeze-thaw durability tests. The curing condition and mixture design are listed below. The content of urea-formaldehyde microcapsules are 1 1% or 2% by weight of cement, and the content of PVA microfiber are 1% or 0.2% by volume of specimen. And we conducted the shrinkage tests based on ASTM C157 during the 35-day curing period. And we conducted the freeze-thaw durability tests based on ASTM C66 by obtaining the relative dynamic modulus of concrete specimen over freeze-thaw cycles. So here's the result of shrinkage. As we can see here, with the addition of urea-formaldehyde microcapsules alone, the total shrinkage is reduced by 10% by the end of 35-day curing period. And with the addition of microcapsules and PVA microfibers, the reduction of total shrinkage by the end of 35-day curing period can be as large as 25%. Besides shrinkage test, we also studied the compressive strength, gas permeability, chloride migration coefficient, and porosity of the cementitious composite specimen. As we can see here, this self-healing system can significantly reduce the gas permeability and effectively reduce the chloride migration coefficient of cementitious composite. On the other hand, with the addition of microcapsules and PVA fibers, with the addition of microcapsules alone, the porosity of cementitious composite is increased by 25 to 35%. And with the addition of microcapsules and PVA fibers, the porosity is increased by 125 to 135%. This is mainly because of the surface treatment of PVA fibers makes the fiber hydrophobic, and it will introduce a lot of air voids and form some extra pores during the hydration process. However, since these introduced air voids and form pores during hydration are insulated, which means they are not connected with each other, the compressive strength, the effect of adding this self-healing system in cementitious composite is on compressive strength is limited, with a maximum value of 12%. So here's an SEM picture of a broken urea-formaldehyde microcapsule, and we can see here a lot of crystalline products on the external shell, and some of them are filling the micro cracks along the next to the microcapsule. So we selected some representative points on the shell and in the matrix and conducted the EDX test on it. We can see that the crystalline product is rich of carbon, oxygen, and calcium element, which indicates that the healing product, the crystalline healing product, is probably calcite. And this is a direct evidence showing the healing behavior of this system, self-healing system on healing the microcracks caused by shrinkage. Okay, here's the evolution of relative dynamic modulus of concrete specimen with respect to number of freeze-thaw cycles. As we can see here, for control specimens without the PVA fibers, they both approach the failure after just 54 freeze-thaw cycles, while the self-healing concrete specimens can survive over 700 freeze-thaw cycles with a relative dynamic modulus of over 60%. Moreover, we can develop polynomial polynomial equations to curve fitting the experimental data to predict the value of relative dynamic modulus with respect to number of resource cycles that concrete specimen has been subjected to. And here I gave you two related parameters named damage variable and durability factor. As we can see here, after 54 resource cycles, the control samples without the PVA microfibers have a durability factor of only barely over 60%, while that of self-healing specimens are still very close to, still at 100%. And after 300 resource cycles, the durability factor of self-healing concrete specimen of 1% 700 is over 90%, and for 1% 350 plus PVA have a durability factor still at 100%. And after 732 resource cycles, the durability factor of 1% 700 specimen are still over 80%. And 82%, and that of 100%, 1% 350 plus PVA have a durability factor over 80%. So by employing a 3-parameter weibull distribution model, we can develop equations for predicting the number of resource cycles that concrete specimen can still stand with a known damage level with different reliability levels. Here we selected 3 different reliability levels with 50%, 90%, and 95%. As we can see here, with the increase of the reliability level, the prediction of the number of remaining resource cycles that concrete can still withstand is become smaller, which means that with a higher reliability, the prediction will become more conservative. And also, we compared the prediction based on weibull distribution model and with the curve developed based on the polynomial equation that we developed previously, and also with the experimental data. As can be seen, the weibull distribution model, the weibull distribution model with 50% reliability can provide a more accurate prediction and more close to the experimental data. Here's the prediction for the control specimens, and here's the prediction for the self-healing concrete specimens. So after 300 resource cycles, a cubic concrete sample with a size of 1 inch by 1 inch by 1 inch is collected from the center of the concrete specimen and being subject to the X-ray micro-CT for observing the internal void system. For analyzing the internal void system, we first need to confirm the threshold of the voids. So as we can see here, by choosing a threshold value of 10, 20, and 30, we can see that an increasing number of air voids is highlighted. But the most accurate value should be 18. So I give you a GIF figure showing the change of the highlighted air voids with the increase of threshold. Okay, after confirming the threshold, we need to do the analysis on the for air voids. I selected a representative region of a 2D slice and highlighted 5 voids here. So we all know that there are 2 parameters named circularity and roundness for defining the shape of the voids. And we can see here the green and blue voids. They are typically an air void with micro cracks caused by the freeze-thaw cycles, especially for the green one. We can see here it is actually 2 air voids get connected with each other by the micro cracks caused by the freeze-thaw cycles.
Jialuo, I think you have 2 more minutes.
Oh, okay, sure. And however, the orange one is a closely perfect air voids. We can compare the circularity and roundness value here. We can see that the micro cracks have a higher circularity value, while a lower roundness value, and the perfectly air void has a higher roundness value, which is close to 1, which means that the roundness is a more accurate parameter for defining the shape of the air voids. So after collecting all the information, after collecting the information of all the voids, we can have a histogram of the air voids here. It's easy to determine that the threshold of 0.7 for the uncracked air voids, and for the voids with a roundness smaller than 0.7, they can define it as micro cracks or cracked air voids. And similarly, as we can see here, there's an even distribution of voids from roundness of 0.35 to 0.95. They are actually the microcapsules. And similarly, we can define categorize them into broken microcapsules and unbroken microcapsules. So we can now have the size distribution of the control concrete samples and self-healing concrete samples. As we can see here, the portion of micro cracks of self-healing concrete smaller than that of control samples, which indicates that this self-healing system can effectively heal the micro cracks caused by freeze-thaw damage. Here's the reconstructed pseudo 3D image of the internal void system. As we can see here, a lot of voids are introduced, as shown here for control plus PVA, which is consistent with our previous finding. And for self-healing concrete sample with microcapsules alone, we can see that a lot of isolated voids are shown in the matrix, which are the microcapsules. And we can find that the microcapsules not only provide the healing agent to heal the microcracks, but also after the consumption of the healing agent, it provides extra space for the volume expansion of the liquid in the concrete matrix during the freezing process, just like the air entrainment do. So here's the conclusion. The self-healing system consisting of urea-formaldehyde microcapsules alone or urea-formaldehyde microcapsules and PVA microfibers can effectively mitigate the total shrinkage of cementitious component during the curing period and significantly enhance the freeze-thaw durability of concrete. And the microcapsules play an important role by providing healing agent and extra space for volume expansion of liquid in concrete matrix during freezing process. But PVA microfiber make limited contribution to the freeze-thaw durability enhancement of concrete. And finally, the roundness is a key parameter for distinguishing the micro cracks from the internal air void system in concrete matrix. Okay, thank you. And if you have any questions, I'm willing to answer here.